Hi everyone, welcome to lesson 11. So recently in lesson 10 we started talking about solving equations, and as you may remember, the equations we've solved so far all had variables only on one side of the equal sign. So maybe all the x's were on the left side already, or all the x's were on the right side. But now what we're going to see is equations that have variables on both sides of the equal sign. Other than that difference, most of these equations will be fairly similar to the ones we've already solved. So we really are just kind of practicing more of the same skills. But there is something I need to let you know about right now, which is sometimes when equations have variables on both sides, they don't necessarily have just one solution. So let's take a look at these two problems, and first we'll kind of read what comes before. So you'll see I made a note up here. Our goal for all of the equations in this lesson is to isolate the variable, we've heard that phrase before, on one side of the equation. We've done that before, but sometimes in these equations we'll see variables on both sides. So we will not only be adding or subtracting just regular numbers, we'll be adding and subtracting variables as well. Okay, let's keep reading. So another note here, most equations have one solution. That's what we've seen, to the point where you're probably just used to it and don't really think about it. If there's an equation, it has an answer, such as x equals 2. However, that is actually not the case all the time. Sometimes all variables cancel out, meaning you might do a step where maybe you subtract x on both sides and suddenly all the x's are gone from the equation. So if that happens, one of two things will be your final answer. Either you will have no solution, and that is what you'll say if you end up with a false statement, like 2 equals 5. So if there's no more x and there's just numbers, ask yourself, are those numbers actually equal to each other? In this case, 2 equals 5, that's not true, that's false. So that equation doesn't make any sense. It will never have a solution, so you would say no solution. Sometimes what happens is you end up with a true equation. So sometimes you might answer all real numbers, meaning x could be any real number for your solution. So that's actually an infinite number of solutions. You might see that phrase as well, infinitely many solutions, or all real numbers. And that's what you would answer if there is a true equation at the end, like 6 equals 6. Now again, these situations are kind of rare, but they happen in a very specific situation where your variable cancels out. So no solution or all real numbers, those might be your answers if your variables totally disappear from the problem. Let's take a look at some examples of this. So we're moving on to number 1. 6x minus 8 equals 32 plus 6x. So remember, our goal is to isolate the variable on one side of the equation. So I tend to prefer to get the x on the left side. It doesn't really matter, but that's sort of what I'm used to. So I'm going to notice what x's are already here on the left side. There's already a 6x over here, so that's fine. But I'm noticing that there's a 6x on the right side. I'd like to cancel that out. I'd like to, in a way, move it out of the way. So I'm going to take that 6x on the right side, and I'm going to subtract 6x. Now, remember, with equations, if you do an operation on one side, you have to also do it on the other side to keep the equation balanced. So if I'm subtracting 6x on the right side, I should also subtract 6x on the left side. So my goal in doing this was to get rid of the 6x on the right side. Positive 6x minus 6x cancels. But here's what happens. Over here on the left side, 6x minus 6x, that's 0x. It also cancels. So it's kind of this strange situation where, wait a minute, the x's are just gone. And all we have left is this minus 8, which we'll just call negative 8, equals, and then there's this 32. We can stop at this point because the variables have canceled out. There's no more x. So now I have to decide, is this a problem that has infinitely many solutions where it's all real numbers? I'll just write that phrase up here, infinitely many. solutions, or is there no solution? And here's how we can decide. Look at the equation that's left, -8 equals 32. Is it true or false? True or false? I think we can agree this is false. -8 is not equal to 32. So because this is a false equation, what we would say for our answer is no solution. So the answer to number 1 is there is no answer. There's no equation, or excuse me, there's no value that we could ever plug in for x that would ever make this equation true. The answer is not -8, the answer is not 32, the answer is there is no solution, because the variables canceled out and the numbers that were left were not equal to each other. The equation that was left over was a false equation. Okay, so let's take a look at number 2 so you can see the difference between no solution and all real numbers. Okay, because sometimes they feel similar, but in reality, they're really very important opposites. Okay, here's number 2. -4 plus 2x equals 2x minus 4. Okay, you might notice that both of the sides of this equation are actually the exact same thing. It might not be obvious, but if you take a look at that left side, the -4 plus 2x, if you just rearrange those terms using the commutative property, right, reordering things, you could rewrite it as 2x minus 4, and then you'd see that both sides were equal. However, if you don't notice that, that's fine. Let's approach it in the same way that we did the previous problem. Let's try to isolate the variable on one side of the equation. In this case, our variable is x, and it looks like we have 2x on the right side. So let's get rid of that 2x by subtracting 2x on both sides. So I'm writing minus 2x on both sides of the equal sign. 2x minus 2x is 0x. I'm canceling that out. And then, just like last time, that actually happens on the left side as well. 2x minus 2x cancels out. So once again, the variables have canceled. Let's see what we have left over. On the left side, I have -4 equals, and then on the right side, I have what we were saying as -4, but we can now write -4. -4 equals -4. So now we have to decide, since the variables canceled out, is this a no solution problem, or is this all real numbers? And remember, we get to ask, is this true or false? -4 equals -4, true or false? Well, it's true. -4 is definitely equal to itself. So because we are left with a true equation, what we get to say is the answer is all real numbers. What this means is, I almost would prefer that we would call it any real number, but the phrase we often see is all real numbers. This means x can be anything. We can plug in any number for x, and we will end up with a true equation. It might not be -4 equals -4. It might be 10 equals 10 or 50 equals 50. It doesn't matter, but regardless of what you plug in for x, you will always end up with a true equation in this example. So x can be anything. So we say all real numbers. All right, now these first two problems, we've kind of started off with something a little bit confusing. So I will just say the remaining problems in this lesson, I think almost all of them, or at least most of them, will have solutions. So usually you will get a solution for x, but I wanted to just right away let you know that sometimes you will not get a solution, and you have to tell the difference between, is there actually no solution, or are there infinitely many solutions? In other words, all real numbers. Okay. So we'll keep that in mind. If your x's or your variables cancel out altogether, ask yourself, is the remaining equation true or false? And that will help you decide for your final answer. Let's move on to the next slide. This is number 3 now. You might find this problem a little easier, maybe. So let's take a look. This one will have an answer. I'll just let you know right now. Here's the equation. 8m minus 5 equals -5 minus 4m minus m. So remember, our goal is to isolate the variable on one side of the equation. Generally, I prefer to isolate the variable on the left side. However, before we do that, let's see if there's some simplifying we can do either on one side of the equation or the other. And I'm going to take a moment now to just draw this line down the middle right below the equal sign, just to remind us that there are two sides of our equation. 8m minus 5, there's nothing I can do over there. There's no distributing, no combining, no simplifying I can really do on the left side. But if you look at the right side, negative 5 minus 4m minus m, I can combine the m's together. So negative 4m minus m. I'm going to put a 1 in front of that m. So we know it's really negative 4m minus 1m. And negative 4m minus 1m is really the same thing as negative 4m plus negative 1m. We end up getting negative 5m. So now when I rewrite the problem, I'm going to write 8m minus 5, still on the left side, equals negative 5. And now I'm going to write minus 5m, because I've combined those like terms. Okay, now that we've combined like terms on one side, and we've simplified as much as we can on one side or the other, now we can try to isolate the variable. And I'm going to try to get that variable to the left side. It doesn't have to be the left side, but that's kind of what I'm in the habit of doing, and I think it's a good habit to use. So I'm going to look at the negative 5m that we have on the right side. Let's cancel that out so that there's only variables on the left side. So let's look at that minus 5m or negative 5m. The opposite of minus 5m would be plus 5m. So I'm going to add 5m to both sides. So I'm writing plus 5m. Notice how I'm writing it right underneath the terms that have m. I'm trying to line up my like terms. So on the right side, that minus 5m plus 5m, those cancel out. Here's what I have on the left side. 8m minus 5 and then plus 5m. The 8m plus 5m is now 13m. So now I have 13m minus 5 equals negative 5. At this point, this equation should look a little more familiar and similar to what we had done in our previous lesson. Now we have just the m on the one side of the equation, on the left side. Now we can finish isolating the variable. So 13m minus 5 equals negative 5. Let's add 5 to both sides to try to isolate the variable. Okay, the reason why I'm adding 5 is that it's the opposite of minus 5 over here on the left side. Let's cancel that out. So all that we have left is 13m equals, now on the right side, negative 5 plus 5. In a way, those also cancel out. So you can cross them out, that's fine, but we need to write something on this right side. We can't leave it empty. So remember, if these numbers are canceling out, it's because they add up to 0. So here's what we have, 13m equals 0. Now this might look strange, but we're fine. We can continue. It's okay to have something equal to 0. To finish solving for m, I'm going to divide both sides by 13. So I'm dividing by 13. The 13s cancel out because 13 divided by 13 is 1, so that's 1m equals 0 divided by 13 is 0. So my answer is m equals 0. Okay, I feel like this is an important problem to show you because sometimes students think that 0 can't be an answer or that 0 means there's no solution. That's not true. 0 is a number and it is a solution. Okay, so this is our solution, so we're done. What we can do is we can check our answer like we've done before. So let's just do a quick check. Remember, checking your answer just looks like rewriting the equation but replacing the variable with your answer that you got. So I'm going to rewrite the problem, 8m minus 5 equals, but instead of the m, I'm going to replace it with 0. So it really looks like 8 times 0 minus 5 equals. And then on the other side, let's see, negative 5, sorry, I'm multitasking here. Okay, negative 5 minus 4m minus m. Okay, so each of those m's, I'm writing parentheses and leaving a little space, and inside those parentheses, I'm replacing the m with 0. Okay, so here's what we have. 8 times 0 minus 5 equals negative 5 minus 4 times 0 minus 0. Let's simplify on both sides and just make sure that both sides end up being equal to each other. On the left side, 8 times 0 is 0. 0 minus 5 is negative 5. So that's what I got on the left side. And let's see if it's equal to the right. Let's see, negative 5 minus 4 times 0 is 0. So I'll write negative 5 minus 0 and then minus another 0. Okay, that's still going to be negative 5. Negative 5 minus 0 is negative 5. Minus 0, still negative 5. So as you can see, it's negative 5 equal to negative 5. They are in fact equal, so that means our solution checks and we're good. So our solution there is just m equals 0. And by plugging in, we were just making sure that both sides of the equation are in fact the same when we replace m with our solution of 0. Okay, so maybe that felt really similar to some other problems we had done in our previous lesson, but the big difference was we started off with variables on both sides of the equal sign. So one of our first steps was combining like terms, and then we had to not just add a number, but add a variable. So we had to add 5m to both sides. All right, that was number 3. Let's take a look at number 4. Looks like we have parentheses in this one. So the problem is 3 parentheses, x plus 5 equals 8x. All right, so I think we know whenever we see parentheses, what we want to do is distribute. So let's go ahead and start by distributing the 3 here. So we'll distribute the 3 through the parentheses. So that becomes 3 times x, that's 3x, plus 3 times 5, that's 15. So I'm writing 3x plus 15 equals 8x. Okay, so there's not really any like terms to combine here. I do want to isolate the variable on one side. I've mentioned a couple times now, I like to isolate the variable on the left side. However, it's okay to also do it on the right. So you might notice there's no numbers on the right side, there's just the 8x. So if I subtract 8x on both sides, we'll be left with 0 on the right side, and that might seem confusing. So let's just see an example where we're isolating the variable, but let's just move it to the right side this time. There's more than one way to do this, by the way, in case you can't tell. The longer these problems get, the more possibilities there are, the more possible right ways there are to do things. And I'm not going to make these 6 hours long and showing you every possibility. But just know that if you're doing it a certain way and it's different from how I'm showing you, as long as you end up with the same answer, what you're doing is probably fine. And if you're not sure, you can ask. So I'm going to, let's see, isolate the variable. And this time, since I already have this plus 15 on the left side, I'm going to try to get all the x's on the right side. So because I have 3x plus 15 on the left, let's subtract 3x on both sides. I'm subtracting the 3x because the original 3x was positive. 3x minus 3x is 0. That cancels out. So here's what we have left. Positive 15 is all that we have left on the left side. And then on the right side, 8x minus 3x, that's now 5x. So my equation is 15 equals 5x. All we have to do now is divide both sides by 5. 15 divided by 5 is 3. 5x divided by 5 is just x, and we're done. So our answer, what I have written is 3 equals x. You could, of course, just write x equals 3. It doesn't matter. Both are the same, okay? So if I had done this a different way and taken some different steps, I would still end up with 3 for my final answer. All right, and then finally, let's check. 3 parentheses x plus 5. Instead of x, I'm writing 3. So I'm writing 3 parentheses 3 plus 5 equals, instead of 8x on the other side, I'm going to write 8 times 3. And now we will check to see that both sides are equal. So 3 plus 5 in parentheses, that's 8. 3 times 8 is 24. On the other side, 8 times 3, 24. So 24 equals 24. That shows that both sides of the equation are equal, and we're good, and our solution works. All right, good. So that one involved the distributive property, and I did want you to see that you could isolate the variable on the right side rather than the left side if you prefer. It kind of depends on the problem, whatever you think is easier. All right, that was number 4. All right, number 5. This one is a fraction problem. So this is going to be good practice clearing denominators or clearing fractions. So as you may remember from lesson 10, when we clear or eliminate fractions, I'm just going to write clear, or cancel fractions, there's different ways of saying that. What we're going to do is find the LCD, the least common denominator, and then we will multiply the entire problem by the LCD. Okay, so here's the problem. 3 over 2a minus 1/5 equals 153 over 10 minus 8/5 a. So you can see our denominators are 2, 5, 10, and 5. If you have a lot of different denominators like this, I would recommend seeing if the biggest one will work as an LCD. And I've noticed a lot of the times for these problems, the biggest denominator will work fine for your LCD. And that is the case here. 10 is our biggest denominator, and 2 and 5 go into 10. So it works. It's the least common multiple of 2, 5, and 10. So we're going to multiply the entire problem by 10. And what that will look like is essentially distributing the 10, and I'm going to multiply each term by 10. So the way I like to show this is I'm writing each term in parentheses, just kind of putting little parentheses around each one in the original problem. And next to each term, each fraction, I'm going to write 10. Again, it's like I'm distributing the 10 throughout the whole problem. The purpose of doing this is to cancel out the denominator for every single fraction. So it's about to get a little messy with things canceling, but the end result will be that there will be no more fractions. So let's take a look from left to right. Here we go. So 10 parentheses 3 over 2a. So feel free to put the 10 over 1 if that will help you. Just remember kind of where the 10 is going. Now the whole point in doing this, again, is to cancel out your denominators. So I encourage you to start there. Rather than multiplying the numerator by 10, use the 10 to cancel the denominator. So in this case, the 10 and the 2 can reduce because 10 divided by 2 is 5. So I've just crossed out the 10 and the 2 and written 5 in the numerator. Essentially down here it would be over 1, but I don't need to write anything over 1 because again, there should be no more fractions after I finish this step. So here's what we have left, 5 parentheses. Look at the only thing I haven't crossed out, the 3 in the numerator, that's just 3, and then of course the a. So I've written 5 parentheses 3a. This is going to turn into 15a, by the way. All right, let's do the same thing for the next term. Minus 1/5, but I'm multiplying it by 10. So I'll put the 10 over 1. The 10 and the 5 this time will cancel out. So 10 divided by 5 is 2. So here's what I have left. I have this 2, and then in parentheses I have the 1 from the numerator. 2 times 1 is 2, so I'll just write minus 2 equals. Okay, my next fraction on the other side, 153 over 10. Well, when we multiply by 10, the 10s just cancel out because 10 divided by 10 is just 1. So this is really just 1 times 153, which is 153. Okay, last term, minus 8/5 a. When we multiply this by 10, the 10 cancels with the 5. 10 divided by 5 is 2. 2 times 8a is what I'm going to write. So minus 2 parentheses 8a. That turns into minus 16a. Okay, so if this is the first time seeing something like this, well, it shouldn't be because you saw it in lesson 10, but still, it might feel like the first time still. This is maybe a good time to pause and maybe even rewind a couple minutes and just watch that whole process again. Okay, this is one of the most common problems I get asked about, clearing the fractions. Okay, it's finding a common denominator, then using that common denominator to clear the fraction. So we're distributing the common denominator of 10. Notice how the 10 canceled out each denominator. Okay, so 10 divided by 5, or 10 divided by 2 is 5, 10 divided by 5 was 2, 10 divided by 10 is 1, 10 divided by sorry, 10 divided by 5 is 2. Okay, good. And then what we did next was just essentially multiply whatever was left over. And what we now have is still an equation to solve, but now there's no more fractions. So let's pick up where we left off here. 15a minus 2 equals 153 minus 16a. Now let's work on getting the variables to one side. So I'm going to isolate the variable, and I think the left side will work fine here. So I'm looking at the variables on the right side, that minus 16a. Let's get rid of that. Let's cancel that out. So I'm going to add 16a to both sides. So I'm writing plus 16a on both sides, because minus 16a plus 16a, that will cancel. On the left side, I get to combine 15a plus 16a, that's 31a. Now I'm copying everything else down, so 31a minus 2 equals 153. We're about 2 steps away now. I have all the variables on the left side. Now I'm just working on continuing to isolate it and get it by itself. So I'm going to add 2 to both sides, right under this minus 2. Minus 2 plus 2 cancels out. So I have 31a equals 153 plus 2 is 155. Okay, and my very last step, so here I am, 31a equals 155. I will divide both sides by 31. And a equals, oops, now I'm using my calculator, 155 divided by 31, and thank goodness it's a nice number, 5. All right, good. So that one was a lot of work, and we got our answer of 5. I will remind you how to check. So let's do our check over here. Taking us to our whiteboard to check our answer. Oops. Okay, sorry about that. Check. So my original problem was 3 over 2, and then in parentheses, instead of a, I'm going to write 5, because that was our answer that we got, minus 1/5 equals 153 over 10 minus 8/5, and then here's another a, so I'll replace that a with 5. Okay, so we're going to simplify on both sides, and when we're checking with fractions, we'll just do our operations with fractions as they are. We're not going to clear the denominators as we're checking. Okay, just in case we had done that part wrong. So let's just multiply. 3 over 2 times 5. Remember, this is really 5 over 1, so I'll multiply across. This becomes 15 over 2. All right, and then minus 1/5 equals 153 tenths minus, over here, 8/5 times 5 over 1, actually the 5's cancel out, so this is just minus 8. All right, I have a feeling we're going to need to deal with this in another way, so let me just put that over 1 right now. So here's where we are. 15 over 2 minus 1/5 equals 153 tenths minus 8 over 1. All right, so let's get some common denominators, and I can get a common denominator of 10 as I'm combining my fractions. So let's work on the left side. 15 over 2 minus 1/5. If I get a common denominator of 10, this 2 will be multiplied by 5. The 15 will be multiplied by 5. So that's 75 over 10 minus 1/5. Let's see, 5 times 2 is 10. So 1 times 2 is 2. So I have 2 over 10. So 75 tenths minus 2 tenths, that's 73 tenths. All right. Good. Now, on the left, or on the other side, on the right side, sorry, 153 tenths minus 8 over 1. Okay, still we can use 10 as a common denominator, so I'm going to work on this 8 over 1, multiply by 10 over 10. So I still have the 153 over 10, that's fine, minus 8 times 10 is 80, so 80 over 10 Okay, and look at this. 153 tenths minus 80 tenths is 73 tenths, which is exactly the same as what we got on the other side. So it works. Okay, I've said this before, but I am aware that sometimes the check process feels worse than the equation itself, but I want to make sure you always know that you can check your answer. This is a great thing to do on the test or on a test as you're working on each problem, so you can really be sure that you got your correct answer. And if it doesn't check, then that's a clue to maybe go back and just look over your work and maybe you made a sign error, etc. All right, let's go on back. Okay, so that was number 5. And, okay, looks like we have 6, 7, and 8 to go. All right, so the next one is a decimal problem. And I did take this one from the homework. And I remembered this one because, strangely enough, even though it started off with decimals, the instructions are asking us to give the answer as a fraction, which is a little weird. So that's one of the reasons why I picked this one. All right, so 3.5 plus 0.45x equals 10 minus 0.3x. All right, so what we can do is we can clear the decimals if we want to. What we would do then is multiply everything by, let's see, if I multiply by 10, see the second decimal, the 0.45, that has 2 numbers past the decimal point. We can actually, we would actually need to multiply by 100 to clear that decimal. So if we wanted to clear the decimal, here's what we would do. We would multiply every single term by 100. So remember, just pick a power of 10. Your power of 10 will relate to how many places do you need to move a decimal point, and go by the one where you need to move it the most. So in this problem, it's the 0.45. I need to move that decimal twice, which means I'm going to move every decimal twice. So remember last time how we multiplied by an LCD? This time we're multiplying by a power of 10 to clear those decimals. Okay, some of you might be wondering, do I have to do this? Can I just deal with the decimals as they are? Because I'm using my calculator. Yeah, you can. It becomes a little tricky at the end when you have to give the answer as a fraction. But yes, if you'd rather just leave the decimals as they are, that is also an option. But I'm going to proceed using this method. I might mention another method in a few minutes. All right, so let's carefully multiply each of these terms by 100. All right, 3.5 times 100, that's 350, plus 0.45x times 100, that decimal gets moved twice, that will now become 45x equals. Now this number was already a whole number, okay, but I still need to multiply it by 100. So 10 times 100, that's going to be 1,000, minus 0.3 times 100, that becomes 30. All right, 0.3 times 100, 30, yes. So just off to the side here, as I'm moving the decimal twice, I'm kind of adding a 0 there. So that's minus 30x. So 350 plus 45x equals 1,000 minus 30x. So we've cleared the decimals. Now let's work on isolating the variable. So let's get all the variables on the left side. I'll add 30x to both sides, because I'm adding because of that minus 30x, canceling out. 45x plus 30x is now 75x, and I'm bringing everything else down. So 350 plus 75x equals 1,000. Let's keep going. I will subtract 350 on both sides, because now that I've gotten all the x's on the left side, let's get all the numbers on the right side. So 75x equals 1,000 minus 350 is 650. And now when I divide by 75 on both sides, here's where you might forget the instructions. You might go to your calculator, 650 divided by 75. It ends up being a repeating decimal. It's 8.66666666, etc. Your calculator might round to a 7 at the end or not. That is not what we need for our answer, okay? So the instructions on the homework do ask you to type either an integer or a fraction, not a rounded decimal. So we're going to deal with this fraction as it is. and we're going to reduce if possible, which it is possible here. All right. So how can we reduce? Well, 650 and 75, let's see, they each end in a 0 or a 5, so we could reduce by dividing by 5. Let's divide each part by 5. So I'll use my calculator to help out with that. 650 divided by 5 is 130. 75 divided by 5 is 15. That's still not reduced all the way. So divide by 5 again. 130 divided by 5 is 26. 15 divided by 5 is 3. So we're end up getting 26 over 3. Okay, that can be our answer as a fraction. So kind of a strange problem where we started off using decimals, but we end up with a fraction answer. Now, if you were not planning to clear the decimals, I'm not going to redo the entire problem, but I do want to show you what you can do to take a decimal answer at the end and make sure it's a fraction. So this is number 6, and I'll just remind you about decimals to fractions. Okay, so without doing the entire problem over, what you'd end up getting, you'd end up with, let's see, 0.75x equals, let's see, 6.5. So you'd kind of go through the problem and end up at this step. Okay, so rather than dividing by 75, you'd divide by 0.75. Here's where it gets a little strange. Again, you'd probably go to your calculator and then realize, wait a minute, how do I do this? So take a look at this 6.5 over 0.75. Here's what we can do. We can move those decimals as many places as we need to, as long as you do it to the top and the bottom. So see this 0.75? I need to move that decimal twice. So essentially, here's the multiplying by 100 part that we didn't do. You're essentially multiplying by 100 over 100, which is a form of 1. So it's kind of this strange way of building up your fraction so that it doesn't have decimals in it. So when I multiply by 100, the 0.75 in the denominator just becomes 75. The 6.5 in the numerator becomes 650, and then we're back where we just were, okay? So now it's a fraction, and then you can reduce, and it becomes, it still becomes 26 over 3. So anyway, if you don't clear the decimals at the beginning, you kind of need to clear it at the end here by multiplying by 10 or 100, whatever you need to. Just whatever you do the same thing on the top and the bottom. All right, tricky stuff, I know. All right. Take a little break if you need to. We're going to keep going. We have 2 more problems in this lesson. So that's number 6. We have number 7 and number 8. Okay, so number 7 and number 8 both deal with parentheses. All right, so number 7 not only has parentheses, it has multiple layers of parentheses. Okay, that means we get to distribute when we start. So here's the problem. 4, then there's a square bracket, then 9 minus 3, parentheses, negative 9x minus 1, close parentheses, close square brackets. That's all on the left side, equals 108x plus 48. So the simplifying that we need to do, it's on the left side over here. So let's work from the inside out as we've done before with simplifying expressions. I'm going to distribute into the parentheses. So the thing I'm going to distribute is this minus 3. I'm treating it like a negative 3. Notice what I'm not doing. I'm not doing 9 minus 3 is 6. That would be not the correct order of operations. We definitely need to multiply before we do any adding or subtracting. So that multiplying means distributing here. So the negative 3 is now being distributed. So negative 3 times negative 9x is positive 27x. Negative 3 times negative 1 is positive 3. So I'm writing plus 3. Here's what's still there that I'm going to copy down. I still have a 4 on the outside of these square brackets. I still have this 9. And then I wrote 27x, and now there's kind of a space. What am I supposed to put there? Well, the 27 was positive, so I am going to put a plus sign. Okay, so here's what we have left. 4, square bracket, 9, plus 27x, plus 3. The parentheses are gone, but I do still have the square brackets. So let's continue simplifying, this time inside the square brackets. So now I can combine like terms. The like terms are the 9 plus this 3 over here. 9 plus 3, that would be 12. So here's what I write in my square brackets. I still have that 27x, but now I get to write plus 12. Okay, and again, the 12 came from combining the 9 plus 3. Could I have written 12 plus 27x? Absolutely, yes. Okay, and oops, let's not forget that 4 on the outside. So here's where we are, 4, square bracket, 27x plus 12. Or maybe you wrote 12 plus 27x. Either way is fine. Now we get to distribute this 4. All right, so I'm multiplying the 4 by the 27x, and then the 4 by the 12. So 4 times 27x, that's 108x, plus 4 times 12, that's 48. Okay, so that was a lot of work just simplifying on the left side. If you look over on the right side, what we have over there is still 108x plus 48. Okay, you might be noticing that both sides of the equal sign are exactly the same. 108x plus 48 equals 108x plus 48. This equation will be true no matter what x is. It will be true for any value of x. Plug in any number you want to, it will be true, it will be equal on both sides, so the equation will be true. So I can already recognize that the answer to this problem is going to be all real numbers. Now, if that was a new concept for you a little while ago when we were learning about all real numbers being an option, you might not even recognize that right now, and that's okay. So let's keep going. Let's work on isolating the x on both sides. So maybe I'll try to get the x's on the left side. So that means I'll take this 108x on the right and subtract it. So I'm going to do minus 108x on both sides. That cancels out. All that's left on the right side is 48. And uh-oh, that's the same thing that's on the left side, right? So the 108x minus 108x cancels out. And we're left with 48. So here's where we are, 48 equals 48. Once the x's are gone, now you get to decide, okay, hang on, this is one of those no solution or all real numbers problems. Which is it? Well, remember, it depends on whether the equation that you're left with is true or false. Our equation right now is 48 equals 48. That's true. Okay, so because this is true, what we get to say is this equation is always true. No matter what x is, this equation would end up being equal on both sides. We get to say all real numbers for our answer. What that means is x can be any real number. Okay, no matter what x is, it would result in a true equation on both sides. It would be equal on both sides. Now, maybe you didn't stop at the 48 equals 48. Maybe you'd keep going. Maybe you'd subtract 48 on both sides. Okay, then you end up with 0 equals 0. Still true. Okay, so still you'll end up with the same result. So the 48 isn't really the important part. The fact that you have the same number on both sides. So I'm going to say same on both sides. That's why the answer is all real numbers. Now, if it was 48 equals 47, then we'd have the opposite situation where you would say there's no solution. Okay, so again, back to where we had started this lesson, true versus false. When the variable cancels out, take a look at the numbers that are left and ask yourself, are they equal or not? If they are, your answer is all real numbers. If they're not equal, then your answer would have been no solution. But for this problem, the answer is all real numbers, which means x can be any real number. All right, good. Last problem, number 8. Okay, this is another fraction problem. However, it's different because the fractions are outside of parentheses. So we are going to start this one in a different way. We are not going to try to clear the fractions because that ends up being a little more complicated when there's parentheses involved. So instead, what I'm going to recommend is that we start this one by distributing the fractions through the parentheses. So here's the full problem. This is number 8. 1/3, parentheses, 6y plus 9, close parentheses, minus 9 equals negative 1/4, parentheses, 4y minus 36, close parentheses. All right, so let's distribute our fractions, and what we will find in this problem is actually things cancel out in kind of a nice way. So the fractions do get cleared either way. All right, so let's take a look. 1/3 times 6y, and then 1/3 times 9. All right, both of these numbers are going to be divisible by 3, so things are going to cancel, but we'll write it out. 1/3 times 6y plus 1/3 times 9. And you can write that over 1 if you want, and maybe we'll write it in parentheses. Okay, so 1/3 times 6y plus 1/3 times 9. Okay, put that 6y over 1, put that 9 over 1, and then notice that we can reduce in both cases, right? So with the 1/3 times 6y, the 6 can be divided by 3, we get 2. So it's really like 1 times 2y, or just 2y, plus. Moving on to the 1/3 times 9, the 9 and the 3 cancel out to just 3. So it's really just 1 times 3, which is 3. Okay, that all came from just distributing the fraction and then simplifying. So again, what we did is 1/3 times 6y plus 9. 1/3 times 6y became 2y. 1/3 times 9 became 3. Okay, also still on this side of the equation is this minus 9. That was not in parentheses, so I'm just going to bring that down. So what we have on the left side is 2y plus 3 minus 9 equals. Let's work on the right side. This is going to be similar. There's a fraction over here. It's negative 1/4. And we will distribute that into the parentheses. So the parentheses are 4y minus 36. So negative 1/4 times 4y minus, and then negative 1/4 times 36. Okay, maybe that's confusing. Another way I could write that is, let's see, maybe it seems weird that I separated those. Hang on, let me readjust. Either way, the negative times negative, this is about to become a plus sign. I'm just trying to find a better way to write it. All right, so here's what you can do. Maybe just automatically write a plus, and then here's what I'll write instead. Negative 1/4 times negative 36. Okay, however you want to do it. I honestly don't necessarily write it in this much detail every time. Negative 1/4 times 4y plus, and then negative 1/4 times negative 36. All right, as you may remember, when we distribute with negatives, get ready for signs to change, and that's what's going to happen with each of these terms. So let's simplify. Negative 1/4 times 4y. The 4's cancel out, because 4 divided by 4 is 1. It just becomes negative 1 times 1y. I'm just going to write negative 1y. You could also just write negative y. I do like to have the 1 there. I think it makes it easier as we're working on the problem. Okay, plus. Now let's work on these other two numbers. Negative 1/4 times negative 36. Negative times negative, this is going to be positive. And then 36 divided by 4 is 9. In a way, it's like negative 1 times negative 9 becomes just positive 9. So here we are. Here's the full problem now. 2y plus 3 minus 9 equals negative 1y plus 9. So there's no more parentheses, and look at that, there's no more fractions. So now we get to simplify and continue solving. What we can do next is combine like terms on the left side. Positive 3 minus 9 is minus 6, or negative 6. So I can write 2y minus 6 equals negative 1y plus 9. Let's get the variables on the left side. So I'm going to take that minus 1y and cancel it out. So I'll write plus 1y on both sides. 2y plus 1y is 3y. So I have 3y minus 6 equals All that's left on the right side is just this plus 9, so I'll just write 9. So we're almost done. 3y minus 6 equals 9. Let's add 6 to both sides. Plus 6, plus 6. So what I have left on the left side is 3y equals, and then 9 plus 6 is 15. Just divide by 3 for your last step, and that becomes y equals 5. Okay, we did it. All right, good. So we finished number 8. The last thing we'll do is just check our answer here. All right, so number 8, checking. 1/3, parentheses, 6y. Now instead of the y, I'm going to plug in our answer that we just got, which was 5. And then plus 9, close parentheses, minus 9 equals -1/4, parentheses. Instead of 4y, I'll write 4 times 5, because again, we got y equals 5 for our answer. And then minus 36. Okay, so 1/3, parentheses, 6 times 5 plus 9, close parentheses, minus 9, equals -1/4, parentheses, 4 times 5 minus 36. Remember, when we're checking, we're plugging in, we're replacing a variable with the answer that we got, and then we'll simplify on both sides and just make sure that we're getting the same thing on both sides of the equal sign. So let's use some order of operations. 6 times 5 is 30. 30 plus 9 is 39. So in my parentheses on the left side, I have 1/3 times 39. So 1/3 times 39 minus 9 is what I have on the left side. If I keep going, 1/3 times 39, I can essentially divide the 39 by 3 and get 13. So that's 13 minus 9, which is 4. Okay, so I've gotten 4 on the left side. Let's work on the right side and see if we end up getting the same answer. So on the right side, -1/4, parentheses, 4 times 5 minus 36. So 4 times 5 is 20. 20 minus 36, that's going to be -16 in parentheses. So I have -1/4 times -16. All right, if you put the 16 over 1, let's see, negative times negative, this will be positive. The 16 and the 4 can cancel out because 16 divided by 4 is 4. So this is really -1 times -4, which is also equal to 4. So it checks. Okay, good. So that was lesson 11. Lesson 10 and 11 really go together. This is kind of, I feel like this is where the class kind of levels up. It's really an algebra class now. So a lot going on, but taking the time and effort to go through these problems is really worth it. Knowing how to solve equations, I mean, that's one of the top skills that you're getting from this class. So please, as always, ask for help. And yeah, ask for help, ask questions, keep practicing, keep communicating. I mean, don't suffer alone, okay? So this is hard, it is difficult, but getting better at it will be worth it, because getting better at this now, it will serve you well in the rest of the course and in the courses that you have left. All right, good, so we'll end here, and I will talk to everybody soon. Thank you.